In this video, we are going to focus on solving two-step and multi-step inequalities. This video is going to be very similar to the solving two-step and multi-step equations video because basically the steps to solve these types of problems are going to be the exact same. The only thing we are going to have to be careful of is when we multiply or divide by a negative number. As a result, this is going to be a shorter video because, well, we've already covered this material. If you need to get a longer refresher, go back and watch the solving two-step and multi-step equation videos, and then use this video as another resource. Alright, with that said, let's jump into some examples. In this example, we have 7 minus 2t is less than or equal to 21. As a goal in any of our equations or inequalities, we need to get our variable alone. So first, what is happening to t? We are multiplying it by 2, and then that product is being subtracted from 7. And that number should be less than or equal to 21. So, if we're going to get t alone, we first need to get rid of any constant numbers. I have a 7 here, which is positive, so I need to use the inverse operation of subtraction on both sides to get rid of the 7. 7 minus 7 is 0, which means we are left with a negative 2t, because if I have 0 here minus 2t, that's going to give us negative 2t is less than or equal to 21 minus 7, which is 14. First step complete. Our t is still not alone. We've isolated the variable term, but we have not isolated the variable. T is now being multiplied by a negative 2. So to separate the t from the negative 2, we have to use the inverse operation of multiplication, which is division. And we will divide both sides by a negative 2. Negative 2 divided by negative 2 is a positive 1, meaning we have just one t left. And since we divided by a negative 2, we must flip our inequality. So instead of being less than or equal to, our solution is going to be greater than or equal to. And then 14 divided by a negative 2 is negative 7. So our solution is t is greater than or equal to negative 7. Alright, let's try another example, this time with fractions. For our second example, which involves fractions, we have 4/5 x plus 1/2 is greater than 3/5. What is happening to our variable? Well, first we are multiplying it by 4/5, and then we are adding 1/2 to it. And this sum should be bigger than 3/5. We cannot start getting rid of our 1/2 just yet because we do not have common denominators. I have a denominator of 5, a denominator of 2, and a denominator of 5. So while there are a couple different ways we could approach this, the method I'm going to use is to first get a common denominator. I know my denominators are 5 and 2, and the least common multiple between 5 and 2 is 10. So I am going to start by multiplying everything by 10. And the reason why I'm doing this is because this will not only get us a common denominator, it'll actually simplify our fractions so that we no longer have any fractions. So if I multiply 4/5 by 10, 10 divided by 5 is 2. 2 times 4 is 8. so I have 8x. 10 divided by 1/2, 10 times 1/2 is 5, so I have 8x plus 5 is greater than 10 divided by 5 is 2, 2 times 3 is 6. So I have now rewritten this problem so that I do not have to worry about any fractions. Now we can solve it as we did the previous example. I need to get x all by itself. So first I need to isolate the variable term. I need to get this term all by itself. And I will start by subtracting 5 from both sides. Plus 5 minus 5 becomes 0, and I'm left with 8x on the left. I did not multiply or divide by a negative number, so I still have the greater than symbol, and then 6 minus 5 is 1. Now that we have isolated the variable term, now we have to isolate the variable itself. And to do that, I have to undo the multiplication between 8 and x, so I will have to divide both sides by 8. 8 divided by 8 is 1, and I'm left with x is greater than 1/8. And that is our final solution. I did not have to flip my inequality sign at any point because I did not have to multiply or divide by any negatives. Alright, we're going to do one more example that is more than a two-step problem. This is going to be a multi-step inequality, but if we remember how to solve multi-step equations, this should be a piece of cake for us. So let's take a look at our final example. Here I have 3 plus 2 times the quantity x plus 4 is greater than 3. My goal is to solve for x and get it to be the only thing on the left side. Before I'm able to take care of anything though, I'm going to have to do some distribution. I'm going to have to distribute because I can't get the x alone while it is still in parentheses. So my first step is going to be to distribute the 2 inside the parentheses with multiplication. That will give me 3 plus 2x plus 8 is greater than 3. My second step, I have 2 constants on the left side. So I am going to need to combine like terms. I'm going to have to combine 3 with a positive 8. And 3 plus 8 is 11. So I have 2x plus 11 is greater than 3. Now this should look as the other examples we have done in this video so far looked. I need to isolate my variable term. Right now the variable x is being multiplied by 2 and then added to 11. So to isolate this term, I need to get rid of the plus 11. The inverse operation of addition is subtraction, so I will subtract 11 from both sides. Plus 11 minus 11 is 0. So I am left with 2x is greater than 3 minus 11, which is negative 8. Now that my variable term is isolated, it is time to get the variable itself alone. To undo the multiplication, I must divide. So I will divide both sides by 2. 2 divided by 2 is just 1, so I have 1x, and I'm going to write it over here. Negative 8 divided by 2 is negative 4, And you have to ask yourself, do I need to flip my symbol? Do I need to change my inequality from greater than to less than? And to answer that question, ask yourself, did I divide or multiply by a negative number? The answer is no, so I do not need to change my inequality sign. We end up with x is greater than negative 4, and that is our final answer. I hope you have found this video useful for solving two-step and multi-step inequalities. As I have said from the beginning, the process here is exactly the same as it was for solving two-step and multi-step equations. So if you were good with two-step and multi-step equations, these should be no problem for you. Good luck.